All right, Tony Mormino with HVAC TV here at Tigerflow in Dallas, Texas. We are standing in a finished, about to ship package pump skid, which we think is about 11,000 GPM. Is that right?
That's right.
Great. So we have this unique opportunity today in that we're going to go look at a couple of stages of production of identical units to this one here. So this is a finished one. We're going to go look how this is built from the base up, which is really kind of a unique opportunity, I think. And hopefully we'll give you a flavor for when you would want to use a package pump skid, how it comes together, you know, how the engineering is involved, how it's built, how it ships, everything you'll need to know about package pump skids. So why don't we do a quick introduction? I'm Tony Mormino with HVAC TV. And then we have, oh wait, do you have the pin? Oh, here you go.
Yeah, I'm Leonel Amparano, and I'm the project manager here at Tigerflow.
And thanks for having us.
And I'm Kasey Mitchell. I'm account executive at Insight Partners.
And Kasey, thanks for setting this up and thanks for having us. This is an amazing finished product. And okay, let's go start from the beginning and talk about how these things get built. Okay, great. All right, so we came from the finished plant and Leonel just did a great little intro to the welding of the skid.
This is how a skid fabrication looks like. So pretty much we start with the raw material. We weld it together to form the rectangle that will form the skid. And then we start welding the frame members. And then over that, we put the diamond plate on top of it. So once this is done, we make sure that everything is aligned, that all penetrations on the skid are supposed where they're supposed to. And then we'll go from there and move it to the next stage, which will be the paint booth. So we, in the next, we're going to show you how it looks once it's painted and when we put some of the structural members that will be supporting the house.
Correct. The base and the tread plate.
That's correct. Yeah.
Okay.
So once that's done, what happens next is that in order to start mounting equipment on the skid, we actually go and paint the system. So that way, whenever the system starts to be put together, we don't have to go over the little hidden places once the system it's mounted on.
This thing looks so good. Let's walk around and we'll talk about it a little bit while Doug follows us. So it's painted in your paint booth?
It's painted on the paint booth, and also you can see that, well, not there, but the drains here are connected, right? So everything that has a drain inside the system goes to one of those two drains in there, which they go to an external connection outside the skid.
Nice. In case there's a leak inside or they want to wash it down. And
so another thing that we can see in here is that we have prepared the panel stands for the VFDs, right? So those two pieces there are where the control panels and the VFDs are going to be mounted on.
We got Vanna White up there. There you go.
And these here are for supporting the house once it gets installed too. So the house itself, it's supported, but this is just reinforcements, just to make sure that, you know, whatever conduits we need to run, they're already installed there, and we don't have to do that once the house is installed.
Got it.
So that goes as a part of the plan, Chip.
The one behind us has the housing.
Correct.
And that's got a good cutout. We'll get a shot of that because it shows the foam construction of the wall.
Yeah,
you just cut those holes out as they. Do you put the doors on, or do they do the doors?
They come and do the doors too.
They come and do the doors.
Yeah. So pretty much like the third party that comes and does that, the third party company, they're professional installers for those type of buildings, right? So they do the doors. They know exactly where to do the penetrations, not only for the pipe penetration, but also for the AC units and also fans and windows in case they need it. In this case, this is an enclosed system, so we don't have fans or louvers to circulate air inside it. That's why we only have the HVAC units.
The bar units.
The bar units.
Right. Got it. Kasey, did you want to say something?
Yeah. This is where they finish table.
Why don't we
up there and talk about that thing?
So what we have in here, it's something that we have to do before we actually install some of the larger items. So in this particular case, these are the supports for the expansion tank. So that being a heavy equipment, we make sure that everything we can do in advance, we do it. And in this case, those pieces of channel are for supporting the tank.
Got it. All right, so I think we're at a point where we want to start putting some equipment on this thing.
That's correct.
So let's walk over here and we'll see the next stage.
So good.
Come on over. All right, so now we're at the point where we're putting some gear on here.
Exactly.
Got some pumps, some pipes, some VFDs. Let's kind of walk through where we're at here.
So once we painted the skid, we move that skid and we start putting equipment on it, right? So typically we go from large equipment to smaller equipment, and we build, after that, right? In this case, the first thing we would do is we would start with the pump, the larger pump, and then we would start building from the connection points, towards suction diffusers. In that case, triple duty valves on this side, going through the branches that goes connected to the headers, right? In this case, we're at the stage in which, like I said, we have a suction diffuser, triple duty valves, and the branch connections going into the isolation valves on this side. For this particular one, you can notice that we have the butterfly valves in here going into the suction side of the pump, coming down to the suction diffuser, then going through the pump, then going to this reducer connection here, and also going to the triple duty valve here, going to the main header upwards.
Got it. Now, there's no motors on these pumps.
No. So pretty much what we do is that for this specific case, we had the pump casings available first than the motors, right?
Wow.
So
is that common?
Not necessarily, but sometimes whenever you're gonna get a pump from a manufacturer, they also have to source their motors from another vendor, right?
So if you can get this early, it allows you to continue the progress.
It allowed us to install the rest of the piping, and once we get the motors, we can install them without delaying the fabrication process.
Yeah,
that's also one of the things here at Tigerflow, we're able to work it out, right? If we were like probably other companies were like, okay, we don't have the pump, so we cannot start. Here at Tigerflow, we try to find solutions in which, like, okay, we don't have the motor, but we have the wet end, so we can start working with that.
Right.
So that's exactly what we did in here.
Right, because you've got deadlines. The building's usually coming out of the ground. It's being built in parallel with the pump skid, right?
That's correct. So
Kasey had a good idea because we've got this apart, talking about vertical inline pumps, the coupler, the seal. You want to touch on that for a little bit, Kasey? I'll get out of the way here.
Yeah, so this is kind of what I was talking about inside the pump house is for a vertical inline pump. This coupling, so if you ever have to change the seal, you would change this coupling, pull this out. It's two half pieces, and the seal is right behind it. And you can do this while the motor's still on the inline pump. So that's a huge advantage for a vertical inline pump, is that you can change this seal out without taking the motor off, or without having to laser line it. The vertical inline pumps do not need to be laser lined. So unlike a base mounted pump.
Huge advantage for time saving to change out the seal. And just, for the beginner, I'm always thinking of, like, for the beginner watching, the motor has a shaft that is connected to it, comes out. This coupler connects that shaft to the shaft of the impeller. The impeller is what's in here, which spins and creates the pressure differential and moves the water.
Right.
So there's not a shaft that directly runs through. If you didn't have this coupler on here, it wouldn't be connected. So it's one of the advantages. You take the coupler off, like Kasey said, you change the seal, which is down in here. Nice.
Yeah.
So we've got our pumps. We've got our electrical components coming together over here. You're going to put the expansion tank here, as we talked about earlier. And why don't we look a little bit at the electrical components, kind of see the stage you're in. We'll swap spaces with Doug here.
All right, so after we got the skid painted. We're over here putting equipment on it. This is kind of the electrical side of the pump house. These are our 150 horsepower VFDs on this side that serves the pumps. And then we have some other VFDs that the contractor had us add to this pump house, and their openings below for them to connect to. This is our main disconnect, and this is the bar controller. That's eventually going to be hooked up. So once they finish the headers on this and the rest of the piping, I believe at that point it'll go into the paint booth again. Is that right?
It will go back to the paint booth, and after that, that's when we start the process of installing the house, right? That's when we call the third-party company, KPS in this case, and they will send us the material and the crew to install the house, and we should be able to see some pre-construction there too.
Great.
Yep.
All right, so let's walk back to where we started and go through the finished product, which is about to ship out the door. Sound good?
Yeah.
All right. All right, so we looked at the various stages. Now we're here at a finished product ready to ship with the housing on it. So why don't we talk about, this is going outside, obviously. It has a housing. Who built that? How does that come to happen?
So after we saw, we started with the skid, put everything on top of it, and then at some stage we put the enclosure, right? This enclosure is fabricated by KPS Global Systems. So they typically fabricate enclosures for weather applications.
Mm-hmm.
So on this particular one, everything is all the snow load calculations, wind calculations, everything is it's done through it's tested to a professional engineer.
Right.
All seismic calculations are done. So it has to go through certain regulations depending on the state. We make sure that everything is structurally sound and that we're not going to have any failings on the job site.
No.
So the housing,
Mhm.
is it generally, I think it's a foam panel construction is what I saw earlier. Is that the general construction no matter where it's going, or is it colder climates at a different construction than warmer climates, or?
It really depends, right?
Okay.
We have a general construction, but what do we have different is the fire ratings. But yeah, the design pretty much is what gets approved, but the panel system is the same regardless of where it's going,
Gotcha.
right? So they pretty much what we do is like we send them our drawings, and then based on our drawings, they create the enclosure, and then they send the panels to us, and they send certified installers for those panels, and they build around our skid. So once everything is built, then we go again inside and start doing all the electricals and all the other finishing touches that the system needs. But pretty much that's the way it goes.
So when it ships, depending on what state it's in, it's already meeting all the codes, all the regulations, everything like that. The purchaser doesn't have to worry about that. You're handling all that.
That is correct. And
Okay.
and it really depends on the state. Some states require certain state labels and certification stickers
Right.
that need to be applied to the building before they can actually be shipped.
Right.
So between us and our third party company, we make sure that we go through all the application process with the states to make sure that we're in compliance with the state regulations.
Right. And if you're working with a rep like Insight Partners, Kasey's handling a lot of that through the engineer and through the GC and the architect. It's all coming together. Everybody knows. What
Yeah,
the plan
and
is.
sometimes the actual end user doesn't require, but we always go and do that, right? Just in case it's
Sure.
needed, we have it there.
Right.
But sometimes the end user is not even aware of the limitations or the regulations,
Right.
and we also help them understand what the process, what is needed to be able to go through this process.
Right. And I noticed there's guard units on this, which are through the wall package cooling units,
Right.
very common in
Yeah.
classrooms. How did that come to happen?
Right. So at some point on this particular project, we had to have cooling, but they wanted redundant cooling. So you'll see one barred unit on this side, and we have two on the other end of the unit. So if one goes down, we could still provide the amount of cooling the engineer wants to meet the load inside. Also, when we're coordinating this building, you can see the 30-inch, that's actually the supply going in, and there's another 30-inch pipe going out. So a big feature of this and the pump house in general was how can we get all this on one truckload to make it easier for the contracting team just to pick it up, set it down, and they're basically done, except we're hooking up electrical connections to the VFDs separately. Also, the water connections, obviously, and some drainage connections that we have floor drains inside as well. So we try to minimize what the contractor has to do on site, and this is a big feature of our pump house.
Right. The fewer shipping slips, always the better.
Right.
The fewer packages. So.
Yeah.
And this is a very well built room. This is not a flimsy deal. No.
Yeah. And another thing with this is, you know, we got to figure out the means of egress as well as clearances and how we going to be able to access equipment whenever this has to be maintained.
Right.
So we have double door on this end, and we also have a double door on the side to allow us to get to our equipment. And also we coordinated this hoistway where we can pull out motors out this door. So it allow us to shrink this area a little bit, but still maintain a pathway for it to get out.
That's great. Hey, let's go in there and take a closer look.
Yeah, that's great.
You gonna get the old man climbing into a box footage?
I think you probably should start just by going in without us in the field.
Right.
Okay, yeah, that makes sense.
Why don't we start with the heart of the system?
Good.
The pumps.
Yeah.
Right. So tell us what we're looking at here in terms of, I think it was 2,800 GPM per pump.
Yeah, I think it's actually 2,500, but these are 150 horsepower vertical inline pumps.
Wow.
And you also see that everything in here is painted, so it's beautiful. This particular pump house has all vertical inline, which allows them to line up in a row. And that's how we got the hoist right above it, where they can ever have to move a pump, a motor, they can pull it right out.
So just for someone who might be watching, we get viewers that are around for 30 years and some who are just starting out or interested in the industry. So vertical inline pumps. Can you walk through how is the water going? Where's the motor? Where's the pump?
Yeah, so this is a 30-inch main. For all intents and purposes, this is the return coming to our pump house. So these headers, I think they're 10-inch headers,
These are
12-inch headers dropping down into a suction guide or suction diffuser here. So this serves as a strainer and also serves as a diffuser. This actually helps us with our space where we can get this drop closer so we don't have to have so many pipe links before we enter the pump.
Right. It smooths out the flow.
Exactly.
So pumps, like fans, they don't want turbulence. They don't want all that mixing up.
Just like a turning vane for air.
That's like a turning vane for air, right? Smooths it out. So, and then you've got your pressure gauges. I like the branded pressure gauge. That's pretty cool.
Yep. You come in and you have your volute, and
so the volute is the part that covers encases the impeller.
Encases the impeller, exactly.
And then you have
and coming out the other side,
it's an increaser. Spike increaser. Going to a triple duty valve there.
Right. 90-degree triple duty valve. So this acts as your check valve. This acts as a isolation valve and
balancing
valve.
Did we get it?
Right.
The three of us.
Yes.
Yeah. It's hard. It's funny. I do these videos all the time and I know what it is, but when you're on camera, it's like you're trying to think of the camera. Am I doing this right? But so triple duty valve, check, balancing, and shut off.
Right.
Isolation valve. And then this is the motor of the pump. And then under here is where you would change if you needed to change the seal, right?
Right.
The coupler's in here, is that right?
Right. And this is kind of the advantage of the vertical inline. I was a consulting engineer for 15 years, and this is one of the things that I wish I knew more about vertical inline, about seal changes, how easy they are for a vertical inline pump versus a base mounted pump.
Right.
You'd have to actually remove the pump motor for a base mounted pump. Unlike a vertical inline, you can just go in here and
uncouple it, and it gives you the space to pull the seal out, put the new seal in. Yeah, you don't have to move this.
That's right.
Which is, weighs a few pounds.
Yeah.
And that leads us to the gantry, I guess, which is really, I call it a gantry, but I think you called it a motor trolley. Is that what you?
Yeah, the hoistway.
The hoistway,
right
okay.
above. So you can actually see eventually this is taped up and whatnot for transportation, but there will be a chain fall which would be able to slide through here and allow them to pull a motor over and out the door and put one back in. So
Leonel, anything about the pumps? We have a redundant pump, I believe, right? This is
so there's 5 pumps here. One's redundant, and you can see at the other end, you can see where the bar units are supplying from the end wall we talked about earlier. But anything else that we
well done?
Then we can mention for this project, we have a special requirement from the customer that we needed to make sure that the torque on the flanges was per their standards, right? So we use a torque meter to make sure that everything was torqued properly, and we were also required to include these tags, torque tags, which pretty much it's a 3-tag system, a 3-step tag system in which somebody checks on the work or someone else, and then there's a last third check in which we make sure that whenever this goes into the job site, there's always going to be movement. So this at least gives the confidence to the contractor on the job site that everything was torqued properly. But even though these systems are completely tested in the sense that we make sure that the performance, the condition point for each pump is tested in our shop. So we make sure that the pump functions as it's supposed to. But not only the performance side of it, but also the pressure testing of the whole system. So we cap the system and we put pressure on it and make sure that there are no leaks anywhere on any of the connection points. So we actually double check that not only the bolts and nuts on the flanges are torqued properly, but we also make sure that we put the system under pressure with water and make sure that there are no leaks anywhere in the system. So it's a double check, even though we feel that the tags are not needed because our testing actually goes beyond that, but we still went out and worked with our customer inside, so we could give the end user what they needed regarding their commissioning agents and anything else that might be needed.
Excellent.
Yeah, and we'll have a torque chart for each bolt in this whole pump house, so it allows them to spot check some instead of having to go back to each one where they can spot check. They can feel comfortable that during transit bolts didn't loosen. So this hopefully will save them a lot of time in the field.
And Vic, flange, whatever the customer prefers.
Yeah, we can do big colic, we can do flange, ANSI flanges. That's pretty much what we do. Most of the flanges for HVAC systems is preferred, at least with our customers. But for most plumbing applications, we do the big colic group system
for the plumbing side.
Mm-hmm.
Yeah, we have the grooved, as you can see up in the mains up above. We have some grooved. One for the cap and going outside as well.
All right, so pumps, we got that down. Okay, we talked about the pumps.
Yeah.
Now let's talk about this tank here.
Yeah, so this big tank is a 500-gallon expansion tank for the system. So it's nice that it's able to fit in this pump house. I mean, all the parts and pieces.
Right.
It's one of the things when you start planning a pump house like this, you're not sure how everything's going to fit in here or how you're actually going to get around some of this equipment. That was my concern as being a former engineer. Is I thought it was going to be much tighter, but I think what happened for this case is you realize, oh, that's 30-inch pipe you're looking at in the drawing. So these clearances were much more than at least what I expected. So
it feels very roomy in here.
Right.
I've been in, there's plenty of room in here. But so for someone new, again, what is the purpose of the expansion tank? There's like a bladder in here.
Right.
Correct?
There's a bladder here. And as the pressure of the system, whether it gets hotter or colder and the liquid inside the pipes expand and contract, this allows you to maintain the same pressure in your system. And that bladder will take on that
because the
pressure.
bladder is like a balloon, and the higher pressure, it gives it room to expand rather than expanding out of a pipe, which is not good. So this lets you play around with that. So very nice. Okay, so we've got expansion tank, we got the pumps, we've got some valves we talked about.
Right.
Now, what about something's got to bring power in and then something's got to control the pumps?
Right. So on this wall over here for our 150 horsepower pumps, each will have its own VFD. So, and on the outside, we can see later, but each of these will have its own connection through the wall. So on site, they'll bring up the power to each of these panels individually. And then, and through coordination on the other side over here, we have one VFD that will serve the pump behind here. We'll talk about in a minute for our side filtration unit.
These smaller VFDs here.
And then these two and those two larger VFDs, this was through coordination on site. So this happens a lot during projects is you realize, hey, can we fit more stuff in this pump house?
Right.
You know, can we control something outside this pump house? And Tigerflow was great, being able to allow space in here, punch out on the floor below. You can see we coordinated all this where they could easily have their conduits ready on site for us to sit this pump house down and be ready to rock and roll. So I feel like they didn't have to put these VFDs outside like they were planning on to. They were allowed to put them in our pump house, and we still were able to maintain our clearances, put them in here.
What nice guys.
Yeah.
Yeah,
Yeah, we could do it.
yeah. We're able to work it out.
Well, good. So VFDs, disconnects. We talked a little bit about that. Now, we didn't talk about water filtration, and I'm assuming if they wanted like a glycol feeder, whatever they wanted in here, you could fit it in here, make it bigger, provide it on the side or anything like that. Tigerflow can, right?
Yeah.
Okay. So I think that's a Thompson strainer.
Yeah.
By Miller Lehman. That's one of my favorite products in the industry, honestly. Water filtration. So,
You got it.
so water gets stuff in it.
A really simple solution, but it's basically just a screen filter.
Yeah.
And it has automatic backwash, which we already piped it to the floor. So when they go on site, the only thing they have to pipe is from the outside. This floor drain is piped to the exterior at the base, so they just have to pipe in at that point.
So what's unique about this, if someone's watching, you hear the term basket strainer a lot, which is water comes into the top. There's a cone. It looks like a big coffee filter, but it's metal.
Right.
It strains the water and it comes out of the bottom. This one actually goes the other way.
Right.
So the water comes in here. The cone is inverted. And what happens is the heavier stuff, before it gets into the filter, falls to the base, which is collected. Then that is brought out through the backwash. But then only the finer or lighter stuff gets in the filter. The benefit of that is you're not taking that pressure drop hit because it's falling down to the bottom rather than in the filter.
Right.
Because you might be running this dirty for days.
Right.
So it's a very simple, minute change, but makes a significant difference in the long run.
Yeah, big time.
So Miller Lehman Thompson strainer is what that is. And they've got some videos on their website. People could go and look at that.
So and so what this assembly is, and maybe we should come on this side to see it, but this is coming from our return. You see our 30-inch main we talked about earlier, and we're just bringing some of the water. This 15 horsepower pump will pull water off the main through this air separator. So we need air in the system. This will pull it out and pump it through the Thompson strainer and back through the check valve there and back to our pumps, to our main loop. So this is constantly going to be able to provide filtration for the unit constantly during operation.
So haven't seen one of these before. I know what a bar unit is. If you've been in the industry for more than 10 minutes, you know what a bar unit is.
Yep.
But what's going on with this?
So this is actually the first time we were able to utilize something like this. So, and the reason for that is because we had to install 3 AC bar units on this station, right?
Okay.
So instead of having individual controls for each unit, this specific unit has a main controller that can connect the 3 AC units.
Nice.
And it can toggle them, bypassing one and then going through another one. So it actually, distributes the load for each system.
In the runtime. Yeah.
Yeah. So
Nice.
This like I said, this is the first time we use something like this, but we really like the user interface and the way how easy it was to connect to the actual AC units.
Excellent.
So just a few more features inside the pump house. Right here we have these coupon racks right here. So this is where they'll test samples to be able to figure out the chemical treatment for the water. Right here is a little shock feeder. This is where they'd add the chemicals to the system. And then back here behind the pumps, once you pass the suction diffusers and whatnot on the side, but is this 3-inch line. What we did here was for when they fill the system, so they can fill the system faster with makeup water, we provide a 3-inch fill line. Back here is a 1-inch water makeup line. This will have your pressure reducing valve and whatnot, and have your whole pressure, your makeup water assembly above that plugs into the main. So this 3-inch line will only basically happen one time when they fill the unit.
All right, so there you have it. Package pump skids by Tigerflow. We hope you got something out of that where you're able to bring you some value there. If you want to check out more about their systems, Tigerflow online, tigerflow.com. Tigerflow.com. Check the video description here. I'll have a link in there for Tigerflow. And Insight Partners, Kasey, thank you very much for your time today. Thank you so much for watching. If you liked what you saw, give us a little thumbs up, subscribe to the channel, and share it with someone else. We greatly, greatly appreciate it.